Hey, thank you everyone for having me here at CSSConf Australia. This is the first time that I've been to Australia and it is awesome. It's super cool. Okay, so this talk is called Faster Fonts for Speed Fanatics, and I want to put the emphasis on the word faster, or rather that last syllable, and the reason why is because I'm assuming you're coming in here with a little bit of knowledge, like some foundational knowledge about font optimization and performance, things like WAF and WAF2, like you probably shouldn't be using true type formats anymore, or sparingly if for compatibility, that kind of thing. Maybe a little bit about subsetting, right? So really what this is these are some tips, and they're going to be some really quick things that you can do, or reasonably low effort, hopefully low effort things that you can do to just give that font rendering performance just a little bit more of a shot in the arm. But before I get into the talk per se, I want to introduce myself. My name is Jeremy. I'm currently, as you might notice, I like self-deprecating humor. I said self-deprecating, not self-defecating. Anyway, so I am currently doing some writing for performance on a freelance capacity for Google for their Web Fundamentals portal. So I like to write about performance a lot. I've written for CSS Tricks and a bunch of different stuff. So this is going to be fun, so let's get into it. But before I can get into it in earnest, I want to talk a little bit about how browsers render fonts. And that's important, right? Because fonts load differently than other resources. Different resources interact with the browser differently. CSS will block rendering if it's in the head. If it's not deferred, as in the case of critical CSS, JavaScript may or may not block rendering, depending on how you load it. Images typically don't, but what's common to all of them is that they go through a common process initially. So let's get it up to speed with a quick recap of resource loading. Let's meet the crew. This blocky fella is a server. He holds all of your resources, your fonts, your images, your deepest dreams and desires for your web app. And this is the browser. This cheeky fella takes those resources and makes an experience out of them. And here's the resource. It's the most important player, because without resources, there's really nothing. You just have a server and a blank browser, and that's kind of boring, right? And what happens through all of these, every resource type goes through a different sort of, not different, but like initially, they go through the same sort of thing, right? You have a browser makes a request to the server, and the server may send that response, hopefully vigorously, because we want a vigorous response. So that's good for performance. It should be quick. So don't worry about the resource. He'll be fine. He'll make it. And then this is where things get different. After that resource arrives in the browser then will do different things with it depending on what that resource is. If it's an image, it goes through a decode. There might be some decompression if things are compressed. There will be some amount of render blocking, depending, right? And fonts do some of that, although they do it a little bit differently than CSS. And then eventually, something will render and something will paint to the screen. And my point about all of this, and I know it sounds like I'm kind of going in a weird aside, is that render blocking is all about priorities. Your highest priority items are things like CSS and fonts, and they're high priority, and therefore they do block rendering. Your images are low-ish priority, although some above-the-fold images, or what might be deemed more critical assets, may get a boost in priority. Your JavaScript will be low priority if it is in the footer or if it's deferred, which is good because JavaScript can block rendering if it's loaded improperly. When it comes to fonts, though, browsers speculate, and browsers actually speculate about a lot of things. Like they speculate with CSS. Like if you have a background image that's attached to a selector that's not used in the current document, once the CSS object model and the render tree has been built, then if that selector isn't used on the current page, the browser speculates and says, I don't need that. I'm not downloading that image. And it does that with fonts. It will actually look at text nodes in the document as well as constructing the render tree to see if any fonts are in use. And if they're not, it doesn't use them. It's great. It's sort of like it defers loading in a way. It only loads it if it needs it. But the problem is that this is what it looks like by default. This is my blog, and all of the examples that you will see are going to be from my blog. And this is what it looks like once the CSS has been downloaded and applied but the fonts are in flight. And then as fonts trickle in, and by the way, these are web fonts, fonts that you get from a service that aren't installed on your system, because those will appear immediately, right? What you'll see here is that these fonts trickle in as they are downloaded. And what you're noticing here is at 2.31 seconds, all we're getting is like a heading, but then it's almost 2.5 seconds before the body copy comes in. And this is problematic. I mean, I guess it's not problematic here, right? Because that's not too long to wait. But think about really slow connections, like 2G, which is still a thing. And it could take a long time, and people could be waiting. So we want to speed that up. We want to get things loading better and just more quickly. That's really important because text content is the most important thing. It's what screen readers read. It's what users read, right? And we want that to be available as soon as possible. So that means that web fonts are ripe for performance tuning. So let's get started. This one is going to seem a little bit mundane, maybe, but I like it. I think it's good practical advice, and I will acknowledge that it's not always possible. But if you can, strive to host fonts on your own servers. And it's important. Oh, my GIFs died. Well, sometimes those things happen. What we tend to do is we have a link tag that we'll get from a third-party service, right? And that's great and all. It's good. It's fast. It works. But you know, the problem with it is that we're invoking calls to other cross origins, or rather other origin servers that are hosting those domains. And you really want to consider hosting your own fonts for performance. And the reason why you want to do that is because fewer hosts means less latency. When you have less hosts that you're less unique hosts that you are loading resources from, that's good. And that's because each time you invoke a new connection to another domain, you're going through a process. And some of it's unavoidable. Like, there's going to be at least one, which is your site. But you're going to have DNS lookup time, which may or may not be present depending on any number of levels of DNS cache that might hold that for you and eliminate that wait. There will be TCP time for the handshake. There will be SSL time if you are serving your site over HTTPS, which you should. And that TLS negotiation time does take a little time. So what we see here is a web page test waterfall of cross-origin fonts. And you can see here that I'm using Google fonts. We have fonts.googleapis.com, which has that font face CSS that defines your font faces and then links out to those other fonts, those WAF2s and those WAFs. And then we have fonts.gstatic.com, which is what hosts the fonts. And what you see here is that we have multiple connections being open, and you can see those distinct phases. That teal is DNS, that orange is TCP, and that purpley color or magenta color is SSL time. And we got a speed index of about 3,800, and that's a little slow. It's not great, but I mean, maybe it's not slow, but this is a fairly lean site. This is my blog. It's not very heavy. And because I'm using Google Fonts, well, I'm not blaming Google Fonts because it's a great tool, and I use it. I still use it sometimes. But because we're opening those extra connections, it's kind of delayed a little bit. Now let's see what happens when we put them all in the same origin. We only have that single connection for that first origin that we can't eliminate that. That's, you got to open, your content has to live somewhere, right? And so you can see that there's no more blocking latency for those other cross origins because we're not making calls to them. And our speed index goes down to about 2,500, which is about a 35% improvement. That's pretty solid. That means that the page speed index measures how visually complete a page is within a certain amount of time. And the lower that value is, the better. It's like, performance is great. As an aside, performance is great because it feels like a study of how low can you get your numbers. Like everything feels like, oh, I want to get that number lower. Oh, yes, less kilobytes. That's awesome. So I understand. You can't always host your own fonts. Maybe you have best practices within an organization that say, hey, maybe you need to use a third-party service, or there might be some licensing issues. I get it. It's tough, and that advice is something that not everyone's going to be able to take advantage of. But thankfully, we have something called rel preconnect, and rel preconnect is a resource hint. And we're going to go over quite a few resource hints today. It is a resource hint that will open up early connections to servers before the browser knows it needs to do it. And we know better than the browser what content we're getting and where we're getting our resources from and what resources are being used. And so when we use rel preconnect, we're giving the browser a head start on making those connections, and we're masking that latency. And resource hints are pretty easy to use. You can do them in one of two ways. All resource hints can be used like this. They can be in a link tag, and you see here we just have rel equals preconnect. The href are the domains, and then the cross origin, which you want to add that because that indicates that this is a request or an operation that we're going to perform on a different server. And so that's important to, don't leave that out, because if you leave that out, nothing good happens. Like nothing bad happens, but then nothing else happens, like you don't get the good things. You can also use it as an HTTP response header, which is great because I like it because it separates that logic out of my application markup and puts it instead into an HTTP header. And I feel, personally, I haven't done a lot of testing on this, but I feel that because headers are earlier in the payload, they're above the response body, that you're going to get maybe just a slight better of a head start when you do it this way. But either way is good, and they're both pretty low effort. So without rel preconnect, you can see typical thing, right? Similar to the cross-origin font request thing that we saw initially. Got those multiple connection negotiations going on. But with rel preconnect, you can see, right there, we're parallelizing some of that. And the funny thing is, even though that CSS request to fonts.googleapis.com is a little, you're not going to be able to get much of a head start on it because that link tag is probably not going to be very far from where your CSS link tag is for the font face CSS that it hosts. But you can see that it does, when we go back, it does boost it just a little bit. It gives us a little bit of a head start. But that fonts.g static resolution, that call right there, happens a little bit earlier, like noticeably earlier. And that equates to about a 7% improvement in your speed index. And that's great. Like you might think, 7%, that's nothing. Well, okay, but then put it in perspective. You put 2 lines of code in your HTML, or you just threw in an HTTP response header for a link tag, or for a link header, and you got that. I mean, as far as effort to benefit ratio, I'm sold on that. That's pretty cool. And that's just the median run in web page test. It could be faster, might be a little bit slower, you don't know. So try it out. And a friendly reminder, I did say this, don't forget about cross-origin. That's really important. Rel preconnect support is great. Just about 2/3 of browsers support it. Although this is can I use, so it changes, whenever that data gets updated. But you'll see that once Safari on both platforms comes into the fore, that we're going to have much better support for that. But if your browser doesn't support rel preconnect, maybe you could think about, oh, sorry, I got ahead of myself. If your browser doesn't support rel preconnect, understand that nothing bad is going to happen. And I had a funny GIF here that's not going to play that showed a tractor engine exploding to drive home the point that we tend to think of things as a catastrophe when we use features that might not be supported, right? Like, oh, my layout might break, this might break. Well, yes, I mean, with some feature checking on those things, you can be responsible. But what's great about things like resource hints is that if the browser doesn't understand them, it doesn't matter. It just glosses over it, and it doesn't do anything. So it doesn't break anything, it just means that users get a slightly less optimal experience. So use it without fear. If you can't use rel preconnect, consider rel DNS prefetch. This is also an option. And what rel DNS prefetch does is that instead of opening the entire connection, it will just perform the DNS lookup ahead of time. And that can be not very much time, or it could be significant depending on any number of factors, infrastructure and network factors. And you use it much the same way. You use it in HTML, you can use it as an HTTP response header. In fact, the syntax is pretty much identical to rel preconnect, except you're just doing rel DNS prefetch. And without it, you can see here, those little teal bars are DNS lookups. Without DNS prefetch, they're occurring as they need to. But with it, we're reprioritizing those DNS lookups. And there wasn't a lot of speed index benefit here, but you can definitely see that it does mask some of that latency. And again, 2 lines of code gives you a little bit of a head start. And what's cool about DNS prefetch is that it's supported more widely. It's almost 3/4 of browsers, so use it without fear. Use preconnect. If you can't use preconnect, maybe use DNS prefetch. I don't know. And one thing that's cool, it's sort of a side note, is that hosting your own fonts gives you back some measure of control. Basically, what you regain control of is use of anything within a font face. This could be Unicode range, this could be font display. It's not to say that these third-party services don't give you hooks or won't eventually expose hooks to do these things or don't already do them optimally, but there is no substitute for having control over your own font face. Also, subsetting. If you want to aggressively subset something, that's great. Like say you have a font that you only use a handful of glyphs of, but you don't want it to convert it into a graphic, you can just convert that into a teeny tiny font. Google Fonts does have a beta feature where you can specify a custom subset in a query string, but it is in beta as far as I know. And I don't feel it as convenient personally, but maybe look around and see what you can do. Oh, and easier use of rel preload. You can technically rel preload stuff from Google Fonts, but the file names are like these long, sort of random strings, and I can't tell you if they change or not. So I can't recommend rel preloading something that might change, because then you might be rel preloading stuff that 404s and your browser will throw notices in the console. It might not be a big deal, but then you might just lose a benefit that you thought you once had because things change, because things do change. Friendly reminder, mind the licensing agreements. I'm going to be very vocal about this. Font foundries work hard. Making fonts is hard. I made a crappy font once, and it was hard. So just imagine how incredibly difficult it is to make a really good font and write this EULA that says you cannot embed this, and all of your hard work just gets thrown down the drain because it's out there, and it's not like you can't convert a WAF2 back to a true type font. It's possible. So just be cool. If the EULA says don't embed, please don't embed. Next, we're going to talk about font display for better rendering control. I love font display. I wrote an article about this. What I like about it is the easiest possible way to change how the browser renders fonts, or to override browser default behavior, because we have the font loading API, which is great, but it's JavaScript, and sometimes JavaScript breaks. This is CSS, and it's one line of CSS, and it's really super duper simple. Now, the spec says that font display descriptor for a font face determines how a font face is displayed based on whether and when it is downloaded and ready to use. For spec ease, that's pretty clear, but the way I like to put it is, font display overrides default browser rendering strategies of web fonts. And I like that because it's simple. It's super simple, right there. See that? That's the good stuff. That's the really good stuff. You want to check that out. And because we've got one line, you just drop that in, and if the browser supports it, it does its thing. It does its font display thing. So let's talk about font display, some of the values. Font display auto is the default. So if you don't supply this, this is what the browser fills in if it supports font display. It'll just do what the browser's going to do. And what that usually is that there will be a period of invisible text. Maybe there will be a timeout for that when it flashes to unstyled text, and then it will put the font in. It may be optimal, more or less. Some browsers block rendering of fonts longer than others. Font display swap is the secret sauce. I like this stuff. The browser will display the first locally installed font in a fonts family stack. So let's say you have a web font like, I don't know, Montserrat, right? And then your fallback is Georgia. That's probably a terrible fallback for a system font. But let's say that's what it is, right? So if you have font display swap, it will display Georgia first. And then while it's waiting to get Montserrat, it will swap that font in, and it'll just do it for you. Before you'd have to use a script like Font Face Observer, which you still might if you want to have broader support or the font loading API, but one line of CSS, and this is just done for you. And you can see right here, oh, it doesn't work. The GIFs don't work. This was the flash of invisible text on one side, and what the flash of invisible text does is the font is blocked from rendering, and then it just appears when the web font is downloaded. And then we have flash of unstyled text, which is actually preferable, which I'll explain in a second. The flash of unstyled text is when the first available system font loads immediately, and then there is a shift to the styled text, or the custom font or web font text. And you might be thinking, don't we not want this anymore? Like, I thought we didn't like it when unstyled text was a thing. Oh, yeah, I get it, but it's good because text is never blocked from being read, and that's really important on slow connections because users can read text more quickly while they're waiting for a font to come in. If a font fails to download, text won't be blocked until the flash of invisible text timeout. Some browsers, this could be a little while. I believe Safari used to be quite a long time, and it might still be. That's a long time, like on a slow connection, like 10 seconds, no text if you're waiting on a slow connection. People are going to bounce, man. They're just not going to dig that. And what's cool about it is that your first meaningful paint and speed index metrics of a page can be boosted. More your first meaningful paint than your speed index. So let's take a look at some numbers. Your first meaningful paint under auto is around 3,200. Now this is my blog on a local, just on a throttled local test because I wanted to have very consistent baselines for measurement. But then when you put in swap, it almost drops that by half. And the reason why that's occurring is because something meaningful is hitting the page more quickly. It's looking more visually complete. Your speed index values don't improve that much, but it does improve a slight bit. But again, hey, one line of CSS, and it's a little win. But there are considerations with swap. Don't use it for icon fonts. Use font display block instead. Like, block, what that does is it will block indefinitely. It's like flash of invisible text, but without timeout until a resource is downloaded. But maybe don't use icon fonts. I mean, I don't want to sit up here and tell you what to do, even though I'm sitting up here and telling you what to do. But that links to a article by Chris Coyer with a lot of rationale for why you should use images instead. They might be more accessible. There's definitely an accessibility argument to make. I could do a whole talk on this, but I am not going to. But if it's cool, I understand you have an infrastructure and app architecture that you have to deal with, and I'm mindful of that. But maybe just don't use icon fonts when you get a chance. And also, font swapping causes layout shifting, which can cause reflows in the document as text changes dimensions, because fonts are inherently different from font to font, different line heights, different kernings, all kinds of different stuff. And there's a great tool for this. Oh, hey, look, it's a GIF. Actually, these are all videos, and because I was trying to be performant and not use GIFs, I learned a lesson today. But basically, this is a tool where you can overlay a system font with a custom font, or rather a web font. I don't want to keep calling them custom fonts. You can overlay a web font with a system font, and then you can kind of like tweak the line heights and the letter spacing of each to get them just ever so perfectly lined up, or as good as possible, so that you can write some styles so that the layout shifting is minimized when the font swaps in. And font display optional, I really like this one. Flash of invisible text occurs for a very short time, and on bad connections, the browser skips loading the font or downloads it in the background. So what this means is that initially, the browser, depending on any number of internal behaviors, will decide, maybe I just don't need that font. In the case of Chrome, what it does is it will download that font in the background like a rel prefetch, right? And then it will go ahead and on the next navigation, it won't apply it to the current page, but on the next navigation, it will apply it. That could change. Browser default behaviors do change sometimes, so do your own testing always. And if you want to learn more about font display, check out this article I wrote for CSS Tricks. It goes over things like detecting font display support and then being able to fall back to the font loading API or font face observer. And support's pretty good, 55%. It's like a simple majority. But once Safari on both platforms comes through, it's going to be more than a simple majority. It's going to be fairly widely available. And the best part, again, is if it doesn't support font display, nothing bad happens. Everything just works. It just works. Or it doesn't work, but that's fine because you'll just get the browser defaults, which in this case is not catastrophic breakage. It's just a slightly less optimal experience for those browsers, and that's okay. Next, I want to talk about rel preload for faster font loading, or rather reprioritizing font loading. There's a lot of spec ease here, and normally I would read this, but I'm not going to read this. Instead, I'm going to say, in other words, rel preload initiates an early fetch for a resource before the browser knows it even needs it. And that's great, right? Because, again, we know what our applications and our web pages need before the browser does. Like, the browser's going to speculate. It's going to go, I don't know, I got to examine these text nodes. We can go, hey, browser, look, I know you're trying to do your job. All right, that's fine. But I'm just telling you, you're going to need that font, so go get it. Or anything. It's not just fonts. It's any critical resource. And that's key. Critical resources for rel preload. Basically, things that are above the fold or anything that's crucial to the user experience. So same thing in HTML, a link tag, but there are a couple of extra things. We have an as attribute, right? And that is the nature of the content, which is any list of keywords that you can find in the preload spec. For fonts, it's font. For scripts, it's script. For styles, it's style. And you can use it as an HTTP response header. And you'll see that little no push thing over there, which I'm going to talk about a little bit later and some caveats. Without any font preloading, this is a waterfall sort of, or not a waterfall, a critical request chain diagram in Lighthouse. You can see without any font preloading going on, or even CSS preloading with your font faces, it's a nested critical request chain. That means that rendering is being blocked in some capacity. But when we preload the CSS and the fonts, there's no critical request chains. It's just the initial navigation. There's nothing nested. And when you visualize this, this is what it looks like. We got fonts, right? They just sort of happen whenever the browser finds them, and that's cool. There's nothing wrong with that. But if you reprioritize with rel preload, what you see is those fonts come in quicker. They're starting to happen as soon as the document is pulled down and the browser discovers that resource hint, that preload link, and then it just goes and gets those fonts without, just because you told it to, which is cool. And the effects are interesting. And you might think, oh man, we're delaying rendering by 0.1 seconds. But let's stop and look at this a little bit, right? Because performance is a game of human perception. And what you'll see up top is that this is my blog rendering without preload up top. And what's cool about this is that I'm using font display, so yes, it's more visually complete than if I relied on default rendering behaviors. But what you'll notice is that even though I'm delaying rendering by 0.1 seconds on the bottom where I do use rel preload, that text is rendered complete more quickly. And I think that that's a reasonable trade-off to make, that you're basically bypassing that entire flash of whatever, right? Friendly reminders. Omitting the as attribute causes resources to be downloaded twice. Supply a value of font for fonts. Supply the resource's content type attribute, so browsers don't download resources they can't use. This is like a content type. I have just 1 minute. OK. You must specify a cross-origin attribute for font resources. Yes, even for fonts on your own server. That's important. A few more things. Don't preload things you aren't going to use in the page. That's important. It's tempting to do that, like for a future navigation, but you want to use rel prefetch instead for that, which is for non-critical resources. Don't preload everything in the kitchen sink. You don't want to preload everything. Just think critical stuff. Think things you need. And if you're going to specify rel preload as an HTTP header, use the no push flag to prevent unwanted server pushes. I like server push. I think there are good things about it. But it's kind of tough. And Jake Archibald wrote a good article about the varying levels of browser cache and how those things can interact. And you might want to disable server pushes, because server pushes are often kicked off by these link preload headers. So be aware of that. You don't want suboptimal behavior to happen. Do you have time for one more? OK, cool. This last one will go quick, I promise. Save data, which is a client hint. And you can use it to skip nice-to-have typefaces. And I'm not going to read this. That's the spec. I'm going to tell you what it says. Save data is a header sent by clients in a data saver mode. Hint, Chrome for Android. Applications can deliver less resources if it is present, if you detect that header and you modify application delivery based on that header's presence or absence. So in this case, you can toggle it in Chrome for Android. You can also download the browser extension for Chrome to turn it on. And then what happens is you'll see at the bottom, there's a little save data on request header. And you can use that to do a number of things. You can use it as a hook. You can serve low-resolution imagery for high-resolution screens. That's cool. You can stream lower-quality video. You can opt out of server pushes. You can opt out of non-essential media altogether. Think big, giant hero videos, right? And then, well, maybe you just want a hero image instead because somebody's asking you to help them save data. So you could just send them less stuff. Or you could opt out of nice-to-have web fonts. If you want to detect save data, you just check for that header. You can see here, by default, I have a save data variable that's false. I check for it. If it's available, it's true. Then you can add a class to the HTML element. Here, I have a no save data class if save data isn't on, and I target that in CSS. By default, I'm opting out of these nice-to-have fonts. But then if no save data is present, it will add that font. And that's good because the way that browsers speculate, it'll use the CSS object model in the render tree and compare it and see if it needs that font. Even if the font face reference is in there, it will just say, nah, don't download it. Or, yeah, download that nice-to-have typeface. And without it, you can see on my blog here, there's like 50-ish K of typefaces without saved data. With saved data, though, just 10, because I cut out these Fira Sans body copy fonts. You can see on the left, without it, we just have Fira Sans for body copy. That's nice. But if save data is on, we just go to like regular body copy. And that's cool, like just system font stuff. If you want to learn more about saved data, you can check out this article I wrote on CSS tricks. Time to wrap it up. Thank you so much for having me. The organizers are incredible. These are people who organized the event. I'm sorry I left out some of the other organizers. I apologize. There are other people here who have either helped me look over my talk and make sure I got some things right, or have written incredible resources that I really depend on to write this and be accurate, or as accurate as it can be. And thank you. Thank you so much.